Right now, hundreds of miles above our heads, there's a new kind of gold rush happening. But it's not for gold or oil or any precious metal. It's for something way more valuable in today's world: total global connectivity. So let's dive into this new space race because it's completely rewriting the rules for our planet's digital future. And look, this isn't just about getting slightly faster Wi-Fi on your next flight. No, we're talking about a fundamental shift: the creation of a seamless digital backbone for everything. Entire industries, mobility, healthcare, manufacturing, you name it. This is the blueprint for the next generation of our connected world. So here's what we're going to cover. First, we'll get into the mind-boggling economic stakes. Then, we'll look at the incredible tech making it all happen. And, of course, the companies you need to watch. We'll also face the very real dangers of this new frontier. And finally, we'll explore the brilliant solutions being built for a sustainable future up there. So why all the fuss? What's driving this insane level of investment? And why right now? Well, the answer, as it often is, comes down to money. A staggering amount of it, tied to the value of a truly connected planet. You know, we hear the term better connections thrown around all the time. But what does that actually mean in dollars and cents? What's the real economic firepower behind it? The numbers are pretty wild. Get this. According to McKinsey, by 2030, we could be looking at up to $2 trillion added to global GDP every single year. And the crazy part? That's just from 4 sectors. We're not talking about just growth here. This is a full-blown economic transformation. And make no mistake, this isn't just a Silicon Valley thing. Sure, North America has the biggest slice of the pie for now, but look at Europe and the Asia-Pacific region. They are right in the thick of it. This is absolutely a global race, with serious players on every single continent. Okay, so that covers the why, the insane amount of money on the table. But now, let's get into the how. There are 2 game-changing technologies that are really pouring fuel on this fire, making this whole new infrastructure in the sky even possible. First up, you've got these things called low Earth orbit constellations, or LEO. Now, instead of one giant satellite really far away, companies are launching thousands of smaller ones that are way, way closer to Earth. You can picture it like a super dense net of connectivity wrapping around the entire globe, which slashes the annoying signal delay, the latency that we're all used to. The second huge piece of this puzzle is laser communications. Yeah, lasers. Instead of old-school radio waves, these new satellites are basically talking to each other with beams of light. This means they can shoot way more data, way faster. Plus, it's a whole lot more secure because trying to intercept a super-focused beam of light in space, good luck with that. And the speed at which this tech is being adopted is, well, it's just astonishing. The market for these laser comms is set to just skyrocket from less than $1 billion today to almost $18 billion by 2032. That's an annual growth rate of over 45%. That's not evolution, that's an explosion. And here's the kicker. This isn't some separate space system that lives in its own little world. Oh no. The very standards for next-gen 5G are being built to integrate satellite access from the ground up. The whole point is to create one massive, seamless network that completely blurs the line between the cell tower down the street and the satellites whizzing overhead. So who are the pioneers? Who are the prospectors out on this new digital frontier? Well, it's a fascinating mix of old-school giants and super nimble newcomers, all scrambling for a piece of this new orbital economy. Let's take a quick look at some of the key players here. You've got the communications veterans like Iridium and Viasat, connecting everything from remote mining sites to your in-flight Wi-Fi. Then there are the data wizards like Planet Labs, who are literally taking a picture of the entire Earth every single day, creating this unbelievable data archive for AI to analyze. And of course, none of this even gets off the ground, literally, without companies like Rocket Lab, who are the delivery guys for this whole operation. Each one is carving out a vital piece of this ecosystem. But with all this incredible opportunity comes, you guessed it, incredible risk. This new orbital infrastructure is unbelievably powerful, but it's also turning out to be unbelievably fragile. And as we rely on it more and more, our vulnerability just keeps going up. And this isn't some theoretical what-if scenario. Just imagine this: a huge network, like Starlink, suddenly goes down. What was the cause? Not a solar flare, not some hostile attack, not a hardware failure in space, but a single, flawed software update. An update pushed to the ground stations that just collapsed the entire system's brain.
The fallout from that would be immediate, and it would be devastating. At its worst point, global connectivity on that network could plunge by a mind-blowing 84%. For more than 2.5 hours, a huge chunk of the digital world just goes dark.
So who feels the pain when something like that happens? Well, just about everyone. Civil aviation suddenly loses critical data from planes that are in mid-flight. Global supply chains seize up as container ships are suddenly sailing blind. Financial markets are thrown into total chaos. And of course, vital military and government communications, everywhere from active battlefields to disaster relief zones, just go silent.
Okay, the risks are clear. They're big, they're scary, but the rewards are just as big. So the real question becomes, how do we do this right? How do we build a future in space that's not just powerful, but also resilient and sustainable? Let's check out some of the solutions already in the works.
One of the biggest problems up there is just junk, space debris. A company called Astroscale, though, has this amazing patented method to clean it all up. It's basically a reusable tow truck that grabs a big piece of trash, hands it off to another vehicle called a shepherd, which then guides the junk to burn up safely in the atmosphere. The tow truck is then free to go grab the next piece. It's like an orbital garbage service, and it's absolutely crucial for keeping those space highways clear. And to fight the risk of those catastrophic outages, another key idea is to build hybrid systems. It's like not putting all your eggs in one basket. Instead of just relying on that one LEO layer, these new architectures combine its speed with the stability and broader coverage of the older, higher orbit satellites. This creates built-in redundancy, so if one layer has a problem, traffic just gets rerouted instantly. The network stays on. And all of this brings us to what might be the biggest question of all. This new infrastructure is becoming absolutely critical to our global economy, to our security, to everything. Yet it's mostly being built and controlled by private companies. So as we race ahead, the most important challenge might not be technical at all, but political. Who gets to write the rules for the road in this new sky?